Hi, Mr. Abundance. How are you doing? I'm good. I'm doing great. Having a great time. I still missed it. ¿Cómo estás? Estoy bien, estoy bien. ¿Cómo te va? Megan, how's the day going so far? Yeah. Why? Just boring? Not fun? A lot of work? The oven is heating from a monster. Okay. Well, that's I guess that's something to look forward to. So that's good. That'll make the day better, I think. Um, Not nutritionally better, but it'll, I guess, make your just overall mood better, probably a little bit, if I had to guess. Woke up for no reason. Barely had any work to do. It's not warm outside. Yeah. All right. That all makes sense. I feel you. Haven't eaten anything, so it's okay. Well, it's good that you're eating something at least. Now, could there be better decisions made? Sure, but you're right. I'm glad you're eating something. All right. Especially if you didn't have your swig of lemonade this morning. Mommy yelled at me for drinking out of the lemonade. Just like she doesn't want you drinking straight out of it. Like, what are we talking? Is this like a 2 liter bottle of lemonade that you're drinking out of? Is it like a carton? What's what's going on here? What's the setup? A Simply lemonade bottle. Okay. Yelled at for drinking lemonade. That's what this world has come to. You know, can't even take a drink of lemonade these days without getting yelled at. I swear. On my last nerve. All right. So let's crush this. Yesterday, we first talked about solving systems. I showed you how you can do it on your graphing calculator. Right. Still waiting on a few stragglers to send me the work from the homework from Wednesday. Right. Solving the 3 equation systems, 3 variable systems by hand. Okay. So if you're one of those stragglers, please go ahead and get it in. You can see on Summit, I have your checkpoints marked. We talked about nonlinear systems, and we did a couple examples of how we can solve them, which we're still basically doing by substitution and elimination. The only difference is sometimes when we plug in a value, in order to solve the equation, we might need a factor, so we might get multiple values, multiple solutions. And we can get anywhere from 0 to 4 solutions. How's your day going? My day's going pretty well. It's pretty chill so far. Mostly giving a lot of performance tasks in my classes, so haven't had to actually teach much. calculus, sent out a performance task, and then we played some Connect 4. That was fun. The fourth block, they've just been working on the performance task for the past day or so, and so they just answer a couple questions about that. So now here we are. This is my first actual teaching of the day, which is good because the less teaching I do, the better for everybody, since I don't know what I'm talking about. But all right. So I got 2 more examples for us to cruise through for the nonlinear systems. This is true. You had to work in Japan because the U.S. wouldn't hire you. Exactly. Applied at literally every school in the United States and nothing. Absolutely nothing. So instead, I had to move to Vietnam and teach there. Right? Get a new identity. Once I had my new identity, then the United States schools didn't know that they shouldn't hire me. So I'm back in the game. Couldn't keep me out for long. But all right, so I have the system. I need to choose, just like before with elimination, do I want to eliminate the x terms or do I want to eliminate the y terms? Okay. In this case, I should be able to make a good decision in that I'm looking at the y's, minus y plus y squared, or minus y squared plus y squared, minus 12y plus 12y. So that's a good choice for me. If I tried to do the x's, that 12 and 33 would really screw things up for me. Right? 2x squared and x squared, okay, if I just multiply the second equation by -2, I could get those to match up, but then the x terms wouldn't match up. And so remember what I said yesterday is we want all the x's to be eliminated at once, or we want all the y's to be eliminated at once. Either way. Okay, but we have to get everything in one step, one swoop. So let's stick with the y's. So this is already set up perfectly for us to add these together, which would give me 3x squared plus 45x. Whoa. Negative 12y plus 12y is 0. Plus 162 equals 0. Okay, so I want to try to solve this for x. So like we said, we're going to have to probably do some factoring. So I first see that there's a GCF of 3, so I'll pull that out. All right, GCF of 3, so 45 divided by 3 is like 15, yeah. Plus 162, let me grab my calculator. 54. And then factor, so 2 numbers that multiply to make 54, but add together to make 15, 9 and 6. So x plus 6, x plus 9 equals 0. Solve each of those, so I'd get x equals -6, or I'd get x equals -9. All right, so that's a good first step for me. Now I need to go through and in separate cases, individually, first I'll go back in and plug in the x equals -6. Then I'll start over and I'll go back in and plug in -9. Okay, we have to plug in both separately because they might give us different answers. Sometimes they might give us the same, but they might give us different answers. We can choose either the first equation or the second equation to plug into. I'll go ahead and do the second one just because it has smaller values. So x squared, so -6 squared plus y squared plus 12 times x, which is -6, plus 12y plus 63 equals 0. right, let's just do some calculating and simplifying. (12 times -6, -72, plus 12y plus 63 equals 0. All right, let's simplify all those constant terms. So positive 36 minus 72 plus 63 is 27. So I end up with y squared plus 12y plus 27 equals 0. I can see that I can factor this as well. This would factor into y plus 9 and y plus 3. So again, I get two different answers, y equals -9 and y equals -3. All right, so this is all from just when I plugged in -6. Whoa. So when I plugged in -6, I got two different answers. I got -9 and I got -3. So that means this is telling me two solutions, right? 2 points, 2 coordinates. So -6 and -9. And I know if I plug in -6, I'll also get -3 as the y value. So here's two of the solutions. Now we're going to do the same thing, but with -9. So we're going to take one of our first equations and plug in that x equals -9. So I'll use the same equation that I used before. -9 squared plus y squared plus 12 times -9 plus 12y plus 63 equals 0. Let's just do a little bit of calculation. -9 squared, 81. 12 times -9, -108, plus 12y plus 63 equals 0. And now we'll actually add all of our constants together. So 81 minus 108 plus 63 be 36. So y squared plus 12y plus 36 equals 0. And looking at this trinomial, trying to factor it, so two numbers that multiply to make 36 but add together to make 12. So that's just two of the same number, right? 6 and 6. So this factors into y plus 6 times y plus 6, or y plus 6 squared, whatever. And in either case, if I solve, then I'll get y equals -6. So this creates a different solution. Now, I also know if I plug in -9, which we solved for before, then the y value that's corresponded with that is -6. So I'll also write that. So if I plug in -9, we get -6. And so these are my solutions. And so this is one of those that I was talking about where we have 3 solutions. And I will show you what that looks like graphically. So for these two graphs, right, that's this red curve is the first one, so it's a hyperbola. The second curve, this blue one, is just a circle. And I can see, so they intersect in 3 points. They intersect here, -6, -3, -6, -9, and then right here as well. Oh, it won't let me click on it. Maybe I zoom in. Doesn't want to stay up, but -9, -6, which is that other point that we solved for. So when we solve these algebraically, all we're doing is considering basically like if these were graphed out, where would they intersect? Well, these 3 intersection points. Right, and those next 2 are for our next 2 equations. Okay, so let's do one last one. So I have 2 nonlinear equations, or a system of nonlinear equations. Again, we have to decide, should we eliminate the x's first or eliminate the y's first? It doesn't matter which one. We could choose. If we chose the x's, we would have to multiply that first equation by 8, I think, or -8. And so yeah, Megan, I think the y values will be the easiest ones since they're already the same coefficients. Y squared, 16y, 16y. So let's just multiply this by a negative. So -x squared minus y squared plus 4x minus 16y minus 58 equals 0. And we'll keep the second one exactly the same. You guys can't see that. Let's bring it down. There we go. Now I'll add these 2 together. So just go column by column. 7x squared minus 28x. The y's cancel. -58 plus 23, -35 equals 0. And let's solve by factoring. So I see that these all have a GCF of 7. So x squared minus 4x minus 5 equals 0. I feel confident in being able to factor that. That factors into x minus 5 and x plus 1 equals 0. So I get 2 cases. I either get x equals positive 5 or x equals -1. So we have to plug in both, but separately. So you can start by plugging in 5 or start by plugging in -1. It doesn't matter which. Let's go ahead and start. Let's plug in 5 first. And I'll choose my first equation. Doesn't particularly matter. But the first equation just doesn't have the 8 in front of the x squared. So that's why it seems easier, I guess. X squared plus y squared minus 4 times x plus 16y plus 58 equals 0. (25) plus y squared minus 20 plus 16y plus 58 equals 0. 25 minus 20 is 5. 5 plus 58 is 63. leaving me with y squared plus 16y plus 63 equals 0. I can factor this. Nine times 7 is 63. 9 plus 7 is 16. So we can factor here and get two solutions. Y equals -9 and y equals -7. So again, these came from whenever I plugged in 5 as my x value. So 5, -9, and 5, -7. So these are two of the solutions. But I still have to go through and plug in my other x value as well. I'll use the same equation, because why not? Except now I'm going to plug in -1. -1 squared plus y squared minus 4 times -1 plus 16y plus 58 equals 0. Do some calculations. -1 squared is 1. -4 times -1 is +4. And plus 58. 1 plus 4 is 5. 5 plus 58 is 63. Hey, wait a minute. These are the same equations. So just recognizing that, I mean, you could still go through and just factor and solve, but since we already did that, I already know that the answers I get out of that are y equals -9 and y equals -7. But keep in mind, these represent different solutions because these are the values that we got whenever we plugged in -1. All right, so it's not like these are repeats and we just need to ignore them. No, it's important, even though the y values are the same, the x value is different. We started with an x value of -1, but before we started with an x value of 5. So these represent two different points where the x value changes. The x value is -1, but y value is still -9. X value, oops, why am I writing x? -1, y value, -7. I guess I should circle all of them together. So my solutions are these 4 points. And I'll pull that up on the graph. Okay, here's my first one, which is a circle. A really neat circle. And my second equation is an ellipse. And I should be able to see that these clearly intersect in 4 points. -1, -7, -1, -9, +5, -7, +5, -9. Exactly the same 4 points that we just solved for.